right, so we're going to take a look at the kind of the harder piece of our story. So I want to go a little bit slowly through this so I don't kind of overplay it. But I kind of think of this as multi-step inverse trig. We don't need to do this very frequently, but I kind of just wanted to paint the picture here. So keep in mind that in normal trigonometry, I would always give you the angle, and then the answer was a ratio. SOHCAHTOA, opposite of hypotenuse. You know, that simple SOHCAHTOA. Your answer was a ratio. But in inverse trig, remember, you swap the domain and range. So that means instead I'm going to give you the ratio, and you're going to give me the answer, so in the form of an angle. So it's really important to keep in mind that the answer to an inverse trig question is what was that angle. So that's a really important piece of that story. So remember, in that previous video, I had a whole bunch of problems where I was giving you ratios, and then we were coming back and finding the angle that would produce that ratio. That is a very difficult concept for a lot of people to understand. So I understand if that felt awkward to you. But in the next video, what we're going to do is we're going to look at kind of multi-step problems. So again, I'm going to hold this up right here. I'm just going to use this because we've been using this a little bit. So what I mean by a multi-step problem is the following. So imagine that instead of some of what we were doing, I asked you to take the sine. Now, please understand, that is just a sine. That's not asking you inverse. There's no -1. I'm asking you for the opposite over hypotenuse. I'm asking you for the ratio of the inverse cosine of 1/2. Well, that's kind of a weird story, isn't it? So the answer to this portion of the question, because remember, in order of operations, you always go to the inside of the story first. So if we were to answer that question, when is the cosine 1/2? And our answer is pi/3. Now, again, we could do that through that, or we could do that through that first piece of the unit circle that I have sitting over here. Remember, we could have said, hey, when is the cosine, when is the x value 1/2? It's pi/3. Remember, the cosine was defined in first or second, and since this is positive, it's first quadrant, all of that stuff. So now, interestingly enough, the answer to this part is the angle, but now I'm saying, hey, by the way, what's the sine of that crazy angle? Oh, so what is the sine of pi/3? Well, the sine of pi/3 is the y value, and it's √3/2, and that's my answer to that question. So we had a brief stop off to find the angle, and then we utilize that angle to find the ratio. So let's try that again. Let's imagine now that I asked you for the cosine of the tangent inverse of √3/3. In fact, I'm going to make that a -1 because I don't want to make the video too long. So again, if we go to our little idea, remember that the answer to an inverse trig function is what is the angle. So this problem is asking me for an angle. So I personally just really like this way better. So when is the tangent √3/3 is the angle pi/6. So the answer to this interior question is the angle pi/6. And then I want to know what is the cosine of that crazy angle. Well, the cosine of pi/6 is right there. It's √3/2. Now, interestingly enough, what you can do sometimes is you can map that a little bit differently. So sometimes what we can do instead is do this through the form of a picture. So I'm going to go over here and say or. Now keep in mind, I told you that the answer to this yellow question is what is the angle theta? So again, I mentioned already that this was defined in the first quadrant because it was positive. So what if I came over here and I drew a picture of it and I put theta right here, and the definition of cosine is adjacent over hypotenuse, and then Pythagorean theorem tells me that that's theta. Now, I know right now that that theta is pi/3, but the interesting thing is, if I just look at the picture and say, what is the sine of that theta? Sine is opposite over hypotenuse. You're going to notice I didn't really even need that theta to find that value. Similarly, in this one, Again, this is my theta right here. The tangent was either first or fourth, and we put it in the fourth because it was negative. The tangent is opposite over adjacent. Now, that's kind of a strange looking one if we do it that way, but it'll work. 3 squared is 9. 9 and 3 is 12, so that makes this 2 roots of 3. That's a little bit awkward, but it does kind of work. I think I did that right. 9 and 3 makes 12, which is 2 roots of 3. That's fine. So what is the cosine? Well, that would be adjacent over hypotenuse. Adjacent over hypotenuse. And that is actually root 3 over 2, because if you rationalize this, that's what pops out. So notice in this secondary picture, I don't actually need to find the angle as I go. So in the worksheet that you're going to be working on the left side, I want you to go ahead and do it the straight way, where you actually answer the question in phases. On the right side, you're going to do it more like what I'm doing over here. Now, I do want to go ahead and give you one more piece here, the cosine of the cosine inverse of the cosine of, let's say, 5 pi over 3. Now, what happens is sometimes people look at these type of problems and they're like, hey, you kind of cheated. 5 pi over 3, I thought we said the cosine was only defined in 1 and 2. That's in quadrant 4. That's kind of weird. Can I do that? Well, yeah, because order of operations says do this first. And I know that the cosine of any kind of pi over 3 is a half. I know that the cosine is positive in the fourth quadrant, so I know it's a positive a half, and I'm done. And so now, if I look at this, there is now an inverse question. Notice the outside question was, what's the cosine? Well, when is the cosine a half? Well, the cosine is a half at pi over 3. And again, it has to be defined in quadrant 1 or 2, again, to make it 1 to 1, but since it's positive, now that's kind of weird. I'm telling you that these inverses did something weird. Notice that the cosine inverse and the cosine don't cancel each other out. We've done that before, how a square and a square root cancel each other out. But the thing is, we've also seen it back in the day. If you took -9 and you squared it and then you square rooted it, you didn't get -9 back, you got +9. So sometimes it's almost the same thing, but a little bit different. So remember that 5 pi over 3 and 1 pi over 3 with a cosine are almost the same thing, but they're just a tiny bit different. And that does make it a little confusing for people. So let's just go a tiny bit further. Let's do one that is like this. The tangent of the sine inverse of 3/5. Now that's going to look a little bit different, because if you're like, well, 3/5, oh, I don't have 3/5. 3/5 isn't here. Again, you're right. We don't have that. What we could do is, we know the sine is going to be in 1 or 4. Remember when we said that the inverse sine was only defined in 1 or 4. So it's 1 because it's positive. The definition of sine is opposite over hypotenuse. Quick Pythagorean theorem. Yes, I rigged this one to be nice. Gives me the number 4. And so now remember, the answer to this is the angle theta. So I'm asking you, all of this is just theta. But interestingly enough, I don't need to find theta. I just need to find what is the tangent of that theta. And that answer would be 3/4. So that's, I'll go ahead and do maybe one more problem like that to kind of mix it up a little bit. How about if we were looking at the cosecant of the cosine inverse of 1/3? Now, that I think would be a little bit harder problem, because I know that the cosine inverse is defined in 1 or 2 in terms of its range, as it turns out. So the cosine, I forgot to make that negative, I meant to, -1/3. Pythagorean theorem says a squared plus b squared is c squared, so that makes this side √8, or 2 roots of 2. So if I now wanted to go find the cosecant of this angle, regardless of the fact that I haven't actually found out what theta is, because I don't need theta, I want the ratio found by theta. So the cosecant is the sine opposite over hypotenuse, but it'd be hypotenuse over opposite. And then I could multiply by root 2 on the top and the bottom, and I'd get 3 roots of 2 over 4. So that's kind of one of those ideas. Now, the final little chunk that's going to be kind of challenging is what happens when somebody does something a little bit challenging, like the sine of the cosine inverse of x. Well, that looks crazy, because one of the problems I have is I don't know where x is. I don't know if x is positive or if it's negative. I have no idea. So as it turns out, I'm not sure. So what I'm going to do is I'm going to draw 2 pictures. One of those pictures is over here, and one of them is over here, because remember, we know that the cosine is in 1 or 2. I keep repeating those to try to help you remember which one's where. But the definition of cosine is adjacent over hypotenuse, kind of like that. Now, again, notice I didn't call this positive x or negative x. I just called it x because x could be positive or x could be negative. Pythagorean theorem, a squared plus b squared is c squared, leads me to this answer right here. Again, if you wanted to, you could do a squared plus b squared equals c squared. Again, I'm trying to find this value b, move it to the other side. If I take the square root, that's what's going to happen. And again, one thing you'll notice is in both cases, it's going up. So I didn't bother to put a plus or minus. They're both going up, and up is always positive. So if we were asked to find the sine of it, remember this is the theta. I'm asking what is the sine of the angle that generated this triangle. So the sine is simply opposite over hypotenuse, opposite over hypotenuse, which is 1, but in this problem, it's exactly the same thing. Last one. How about the tangent of the sine inverse of, let's say, 2 over x? And then I think we'll be done. So if we're looking at this one, again, the sine is defined in 1 or 4. I do not know if x is a positive or a negative, so it could be up here in 1, or it could be down here in 4, which is kind of cool. It makes it just a reflection of itself. The definition of sine is opposite over hypotenuse. Now, in this case, it would be negative 2 over x because it is going down. And then the Pythagorean theorem, a squared plus b squared equals c squared. So that would make this one the square root of x squared minus 4, and that's going to the right. And so if I wanted to know what the tangent is, the tangent of the angle theta, remember theta is this angle here in the middle, the definition of tangent is opposite over adjacent. And in this case, opposite over adjacent as a positive, but also opposite over adjacent as a negative, because there's 2 potential answers. And that may feel a little bit awkward, but I wouldn't know which one it is unless I knew what was actually happening. So anyway, that is the end of my quick discussion. I know there will be questions when we get back, and hopefully we can answer those pretty rapidly when we get back together, because there's a couple little tricks in there. So I will see you back in class soon. I hope you had a great vacation. Bye.